Hello, my name is William McKillop, and I'll be telling you about Lab 4 Oscillation. Introduction. In this lab, we are examining the motion of a spring mass system where the mass swings in an arc while oscillating on the spring. Using the data gathered from our tracker in a CSV file, we are then going to use a model to chart the different energies involved in our system. These energies include the kinetic and potential energies involved in our system from both the spring and gravitation, all changing due to the energy principle. And our time interval is 9.33 seconds. So for tracker, we use tracker to extract the position data of the mass in this video, and it's the video they supply us in the directions of the assignment. After having set up the coordinate axis and used our known distance of 0.7 meters, I charted the path of the weight on the string providing this data. With this, I was able to, along our initial information, m equals 0.402 kg, calculate our k, using k equals 4 pi squared m over r squared, where t represents the interval between our oscillation, giving spring constant of 6.836. mg equals k L minus L naught, with L naught being 0.124 meters. So for the GlowScript code starting, I initialized the values that were provided and calculated based on the data from tracker, setting values like K subscore S to the spring constant found using the oscillations as well as the initial energies using the previous formulas. After, in the loop, I coded the forces involved using fundamental principles we've previously learned and then updated our ball's velocity and position. Following, I updated the separate energies and found their change over the previous time interval to then be graphed. And here's some code surrounding the page. GlowScript model. So that's kind of what that looks like. GlowScript graphs. I'll give you a second to analyze these graphs, and we have a position versus time graph here, change in energy versus time, and you see the different oscillations. What does it mean? For the used oscillations for the lab Y, the oscillation times resulted in a spring constant of K equals 6.836, while for the oscillations for the position, in the x direction resulted similarly with the spring constant of K equals 6.792. This clearly shows that the oscillations in both the x and y directions follow the same timings as the mass oscillates, as seen on the picture on the right. Thank you guys very much.